Hi YouTube, we're here with the ASH26 build update. Got some new components that came in yesterday for us, and they're going to get us to the next step of our testing for our brushless motor and electronic speed control, our power configuration here. If you remember from the last part 3, we had just tested about 25 amps of output, and on this Aeronaut 12.5 prop being pushed by a motor that is by E-Flight, or not E-Flight, E-Max, and actually the sticker popped off of it. This is what the sticker says. But really what it is right here. So what we're going to do today is we're going to figure out which of these electronic speed controllers we're going to use, and we're going to take and weigh them first on our super high precision scale, and then we're going to use that information to tell us, oh, and I got, this is a YEP brand, YEP. This is a 30 amp brushless ESC, and it has an SBEC that is rated for 4 amps at 5.5 volts. I'm just going to write that down so it's easy to remember. 4 amps at 5.5 volts DC, okay? And that's an SBEC. And then this one's the 40 amp variety, SBEC, 5 amps at 5.5 volts DC, which is great for an application like mine, because I'm basically flying a glider and I want the BEC to be good. Now, you could use an external BEC, and you actually can find ESCs without any sort of BEC, but I don't want to do that. I think I'm going to lose on the weight battle. And then I got, this is the YEP programming card, so we'll see how that works. I'm just going to write this on here. If you're interested in ordering any of this stuff, guys, just go to hobbyking.com. That's your part number for the programming card. This is a part number for the 30 amp, which is a great, I mean, these are really nice. They're kind of expensive, but I mean, in my opinion, I'm used to buying the cheapest crap you can find. And guys, I'm leaning toward using this one, but let's just be real. Let's go talk about servos real quick. On this model, I have, of course, the motor, which is handled by the 40 or the 30 amps. This is originally what I bought to use in this plane. If I need extra nose weight, I'm going to use this. And keeping in mind that a plane that has a huge ESC and only uses a quarter of it, it's never going to get hot. The ESC is never going to get hot. You're going to have a lower likelihood of having something die on you. But let's talk about servos like we came out here for. We have one servo, we have 2 servos, we have a 3rd servo, and we have a 4th servo that's going to run the rudder, which is yet to be attached. And then we have, now I'm going to run these as flap-ons, spoiler-on configuration, but then at some point I'm probably going to put in air brakes, even though the guy who sold me this sold them. So there's also one more servo for the landing gear. But let's just be real. The landing gear is going to be running for like 1/10 of a second. It really doesn't even hardly count. Yes, it will load the circuit, and yes, it could load it at a critical time, but like, let's just be real. You're going to be out of the throttle, or you're going to be at like 10% throttle tractoring the motor. So really, landing gear, even if they load the circuit a lot, you almost kind of have to treat them alone. Now, if you're using a stabilizer, those ailerons are going to be trying to level the wing, or try to maintain attitude and roll. So there's going to be a certain amount of output all the time if you're using a stabilizer, which I am using a Lemon RX 7-channel receiver with stabilization. It's actually an 8-channel receiver. You get 6 usable channels unless you want to share with the on-off switch. So right now, this is where we are. This is where we were going to be going, and the difference in weight we'll just bring with us is going to be what we had last time. So all-in weight can't really be calculated and compared here because we don't have ends on there. Now I don't want to put ends on both of these, so let's just do a measurement without the connectors. Obviously the programming card has nothing to do with that. It's not going to go in the airplane. If you guys aren't sure what a programming card is, you're probably not watching this video. But let's suppose you are watching this video and you're not sure what a programming card does. A programming card plugs into the electronic speed control, and it programs the electronic speed control to act in a certain way. And there's a bunch of different factors that you can set up. And like braking, do you want the motor to just tractor with no input, or do you want it to use the magnetic coils to brake, to stop that thing from spinning? And then how hard do you want it to brake? Do you want it to brake fast? Do you want it to brake slow? Do you want it to be soft so that it can still move a little bit? Do you want it to move none? Do you want it to be hard? So it just depends on what you want. The other thing, one of the other settings that you can change would be, of course, how fast you want it to come up to speed, which is important in an application like this. Okay, so this has this little booklet that opens up. Lots of different settings you can change. Okay, and you just hold this, and then these little lights will activate to actually tell you feedback as to what the settings are. I'm going to try to move my fingers off of here so you can see what the settings are, which this is pretty cool. This is way nicer than, see, this says enter, this says 1, this says 2, I believe. So what happens is you move this over, and then you move this up or down, and once you get to you follow the chart over, and it tells you what the setting is, and then you press enter to select it, and it sets that value. So that's pretty cool stuff. Anyway, and then there's 2 pages. I can't remember how you switch between page 1 and page 2, but there is a way to do it. Alright, so real quick, it's been a couple of days. We're going to use some of our state won't calibrate test weights here. And I want to just, let's just see how much this thing weighs, and we'll test it right at that test point. Got to make sure the wires get on there, guys. The wires are going to be part of this equation. Okay, so 45.7 grams. So we're just going to get in here and grab this one. Should be pretty close. Oops, nope. 45.7. Okay, so we'll switch unit of measure. So yeah, so we're 0.1 pounds. So that's right on. So we don't need to worry about calibration being off. Okay, so we've got our 40 amp with the larger SBC, 43.7. So we're going to write that down. Remember, guys, this is not an apples to apples compared to these guys, okay? This is 43.7 because we're going to have lead and lead for solder, or silver, and then an XT60 and the ends, which would be the bigger ones, and I'll show you the part numbers later. So that's going to add a little bit of weight. So this is going to be commensurate, if not even a little bit heavier than this Dealy Bop. But if you recall, this one here at 45.8 grams, we built adapters for. Those adapters would ultimately be somewhat of a wash because we've taken off the smaller plugs and put on the bigger plugs. Okay? So we're going to write that down now. 43.75 grams, and that's for the 40 amp. Okay? And that's before ends, right? Now we're going to take the other one, which is a 30 amp. We're going to make sure we're zeroed when we start our test. 26.85. Okay, grams, and that's the 30 amp. Alright, so 30 amp, 40 amp. So what do we have for a differential in terms of percentage? Well, in terms of percentage, I'm going to use a calculator. We're going to clear the screen. 26.85 over 43.75. So it looks like this one's about 61%. the weight of this one. Now what's the savings there? Obviously the savings is big, okay, because you go from 43.75 minus 26.85 is 16.9 grams. 16.9 grams is a pretty good amount of weight in a plane of this sort. However, a plane of this sort I do not want to crash. A plane of this sort, even though this 30 amp electronic speed control conceivably can run, I want to show you a difference here. See this 40 amp ESC? See how much bigger the heatsink is on this, even the Aerostar that we were using before. Now just keep in mind, this is 3 amps at 5 volts, and that's a BEC. SBECs, switching BECs, are heavier. This is the portion of the circuit that makes a switching BEC work. You don't have that on a regular BEC. You have a different type of circuit in there. It's just on. It just bleeds off the unused voltage and available power and current as heat. So it's less efficient. However, there's a trade-off. It's lighter, okay? In certain applications, you just need them to be lighter. Now let's look and juxtapose that to the 60, okay? Here's your 60 amp, guys. This thing's pretty big, okay? It would not be out of the question to use a 60 amp ESC on that plane, on the Bird of Time, with 117 inch wingspan. That's a little bit heavier, okay? 4 amp. 5.5 volts DC. Okay? What do we know about this one, guys? This one has half the output for the motor, but it has the same SBEC. This is an SBEC. How can you tell? There's a big old bump back here. A big old square thingy. That's how you can tell. Also, this one has a couple capacitors, it looks like, on there. Okay. Capacitors are round. They have pins that come off the end. And they hold charge. They don't, not like a battery, they hold charge. That's the easy way of looking at it. So 76 compared to 26. That's a big difference. This is more than double the weight of this. Obviously, you would never get too terribly hot on here, but you would end up with a lot more weight. So that being understood, we are comparing a bit apples to apples because we don't have the ends. And we don't have the end. Okay? So now that we've got that figured out, let's go ahead and put the ends on, and then we can do some testing. Now, I've kind of made up in my mind initially that I want to go with the 40 amp. But, to be honest with you, I'm really tempted to just see how well this thing's going to perform with a 30 amp ESC. Looking at the motor size, and this is something you can do a lot of times, a motor will tell you it's not got enough ESC by just the size of the heatsink, okay? Look at the size of the motor, look at the size of the ESC. That looks small to me. Now go look at your other planes. I'm not saying that that's some technical way to do it. Of course you can use math. This is going to be a more expensive ESC than your Hobby King Plush, of course. Okay, so you expect this to be more refined than this. They're both Chinese made, but let's just be honest, this is more expensive. They're using better components. Better components cost more, and they're usually lighter, smaller, better. Okay, that being said, you may expect it to be smaller relative to the motor size. Now let's look compared to the Aerostar. It's not that much smaller, guys. In fact, the Aerostar has bigger capacitors here. Okay? But what's different about this and this? This has the switching BEC, which is critical. Now this has reversing. If we were putting this in a water plane, I would go with this any day. Plus I wouldn't maybe be so concerned about weight because it's not a high performance glider. So in this case, we're going to go with this one for now. But what we're going to do is we're going to test it. We're going to see if it gets hot. We're going to just make sure everything seems good. And then while I'm at it, I'll probably go ahead and put ends on. I don't know if you guys want to watch me build these ends. So, not real sure I want to waste your time having that experience. So what I'm going to do is I'm going to go ahead and just do the first pin, and then we'll move on from there. Now one thing I do like about these yellow leads, They're a little easier to see inside the cavity of a plane. And then secondly, they are a little easier to mark with a marker. I usually like to use heat shrink if I know what color they're going to match up with, but since these are black leads, it's real hard to tell anyway. So I'm not going to worry about them. I'm just going to use heat shrink, just black heat shrink. So this is how I'm going to do this today. I'm going to do it real easy. We know what size we need. Oh, real quick, Hobby King, if you're ordering these, that's the part number. This comes with 10 sets. I think there's like 3 something, maybe. Of course, they gotta be in stock. Okay, so I'm gonna take one male, and just to refresh your memory, the motor has a male coming out, the ESC has females. Why do they do that? Because if this were to detach, okay, this is not going to touch something, okay? This, although at this point you wouldn't want one to detach because you could theoretically have some power going through it. Okay, so right here, the male goes into the female, and then we're going to take our forceps. If you don't have a good pair of forceps, just go grab some. They're cheap. You will use them all the time, guys. And I'm big on economy in this process because I like to live life and not just live RC, although that's pretty important to me. You gotta have money to do it, and the more you save on this plane, the more you have for the next one. Of course, this plane is kind of a pet project for me, so I really want it to be awesome. Okay, cleaned tip, got my solder ready. Now you'll notice I didn't slide any heat shrink over. That's because it's going to be the same size, no matter what. Okay, so you'll notice on this one that I can stick that in there, and then that I need to maybe take a little bit off. And when I say off, I mean the outside sheath. Okay, so that's nice. That gets us enough so that we have full penetration. We're not going to give anything up. Okay, so now the next thing we're going to do is we're going to heat this tip. We're going to get a little bit on the outside, but just enough to make contact. Okay. Oh, and then we'll stick this under here. We've done that in the past. That works real well. Then we're going to take and stick this to the side. We're going to make a little bit of a bridge in the solder, and that's going to heat this thing really well. Okay. And then as we're applying heat, we're going to let it heat real hot, and then we're going to stick the solder into the hole. Do not breathe the fumes, even if you don't have leaded solder. Don't trust the manufacturer. There's probably some lead in there still. Okay? Lead will literally make you go insane, so you guys probably think I do a lot of soldering. Oh no! Some flux came out. Okay, so we got that about, I'd say, 75% full. Then we're going to take this, touch the tip, let it warm up. Don't ram it in there, you'll just spill solder everywhere. Okay, now I can tell I'm bottoming out, so I'm going to let that heat for a second. Pull the heating element away. It's getting very hot on my index finger. Hot. Okay, so now it's set up enough to where I can let go. We're going to let that set and cool for a second. So we're going to do that. And then we're going to build an XT60 onto the other end, because that's the choice that I will be using. In this case, we're going to use a female connector, which has male pins in it. And, except we're going to build it, we're going to build the front and the back. If you want to order these parts, I usually get them when I get an order from Lemon RX. Lemon RX is where I get my receivers, because they sell them for really good value, for like 50 cents. For a male and female, if I recall, it might be 60 cents. Here's your part number. It's not really hard to find stuff on Lemon RX website. So that's one way you can do it, or you can go to Hobby King. They just happen to be out of yellow. I got nothing against yellow or black, but in this case, I'd prefer to buy them wherever they're the cheapest. In this case, you can see these 5 pairs. I think this was about the same price as buying these. I like the yellow better because black will obstruct the direction. It's harder to tell the difference between positive and negative because the subtle angle is hard to see out on a black connector. So there's your part number for black ones at Hobby King. The only reason I got those is because they were out of stock on yellow. Anyway, so what we're going to do now, you'll notice I always take another connector, and I'm just trying to use up the ones I got open first. We're just going to take this. We're going to plug in that. Just be careful you don't accidentally build the wrong side. And then of course you need to get a little heat shrink. The heat shrink is going to be important because this will help you to identify positive and negative. Even though you have wire here, when you cover up like this much of it, you may not be seeing the whole wire on an ESC, so I always try to use red and black heat shrink if it's possible in that given installation, and it'll pay dividends later on. Okay, so we got, I think this size will fit, so let's verify that real quick. So obviously you want this to fit around that, plus just maybe a little blob of solder, so that should be plenty good. Nice sharp scissors. Usually give myself about a ½ inch or so. Here's a part number of black. And here's a part number of red. Okay, and so probably what we'll do is we'll go ahead and just get this built up, and we will pause the video, and then you guys can imagine what it'd be like doing the rest of them, because we'll do both of these. And just to humor you all at home, we'll probably go ahead and test both of them for a few minutes too, and that's all provided we can fit it onto this video. I have to do videos in 30-minute chunks just because the nature of the camera I've used. Alright, so the way we build these is pretty straightforward. Also, since we're going to be super weight sensitive on this project, I am going to actually trim these so they're even. I know it sounds stupid, but every little bit counts when you're trying to get performance out of a plane. The lighter it is, generally the better it's going to fly, except for getting CG. If you need weight to make CG, put the weight in. I don't care if it's 2 pounds. Make it right. If the CG's not right, the thing's always going to fly crappy. Same goes for left and right. Left and right, front and back, it all matters. I think front and back might matter a little bit more. Who am I kidding? It all matters about the same. I think you just get away with a little more on the left and the right. Okay, so now we want this side. That's positive, so we'll go ahead and start with positive. So the first thing I usually do is I'll pull this length of solder up, and it'll stand up on its own a little bit. And then I find the side I want to work on, get a little bit of heat to it, make that little bridge, and then I'm actually just going to let this solder run down the side of the inside of that connector. And you see how I'm just walking it up into the solder. Now if you look inside there, see how that solder's run up inside of there? Works pretty good. So then you can take your soldering iron, and if it gets stuck on the front, then you can actually send that to the back. Now, the other thing too that helps is, just like when we did this, we'll actually take and grab this, let go of that connector, and we'll take and grab the other side that we're not soldering. We'll hang on to it. Just be careful you don't get in too bad a habit of doing this, because when you're working on a battery someday, you're going to go try to do that, and you'll short it out, and it'll scare the crap out of you. Probably catch your hand on fire. Not that I've ever done anything of the sort, but you could imagine what it'd be like if I did. Just going to pivot this a little bit. There we go. So when I started doing this a couple years ago, getting back into the hobby of doing airplanes, I've always done radio controlled stuff. Okay, see how the solder came out, guys? I'm going to do something, I'll show you a trick. Okay, I'm going to fling this at that tray. You see how I did that? That got the solder that spilled out. I overdid it. So now you just need to let that cool, and then this little piece will just break right off. Otherwise, it's going to look like crap forever. Sorry about that. Alright guys. Okay, get that thing almost full. And then might as well take the negative side and go on the other side here, so there's no confusion. See, that needs to go in a little deeper to make full purchase on the connector. And believe me, that does make a difference. If you have less contact area, you're going to transmit less power. Okay, so let's see if that's about right. Okay, just a touch too far. So what we'll do is we'll actually go just a little teeny bit less on the other side. Okay, and then like I've told you in the past, I hang on to these things and use them for retaining clips on different size clevises. And okay, so then like that little splatter, take your X-Acto knife, it should just pop right off of there with a little bit of hesitation, and then you won't even know it was there. Okay, so now this tip needs to get tinned a little bit better before we try to penetrate into the other solder. Otherwise you're just going to wick all the solder you put into your pin, socket, whatever that is. Okay, so you'll notice I'm holding this down to the wood. You wouldn't want to do that like on your dining room table if you don't want to end up dead by wife. But this is not a dining room table. It's a workbench table. I have done this stuff on the dining room table though. It's our little secret. Okay guys, man, that is hot. That is super hot. It's kind of killing me. I don't normally do this, but I'm going to use gloves for this because it's just annoying early in the morning. Early in the morning at like 9 o'clock or 9:30. Just be careful when you wear gloves. You do get a bit of a false sense of security. And what I've learned is that sometimes you'll wait a little bit too long to let go of something that's really, really hot. So, see there's one little straggle. I don't know if you guys can make that out. I do not like the way that solder flowed out of there. Because now I annoyingly have to take and fix that. The other thing is I have this rotated so that when I'm done, it's going to have the lines crossing, which is going to be stupid. So what I want to do is I want to take and heat this puddle that I want to disappear. I'm going to actually pull this out. Got to get a lot of heat on it though to do that. There we go. Okay, so I don't know if you guys can see what I'm talking about, but that little puddle there, sorry, the autofocus is not getting it. There's a puddle that went back here that's going to make it hard to get heat shrink in there. So at any rate, you guys get the idea. I'm going to get this on, and then we're going to come right back for some testing. Alright guys, so finally got that one soldered on there. So basically, you got any of that nasty flux left on there, one thing you can do that's probably not a bad idea, certainly not absolutely mandatory, of course, nothing's mandatory on this stuff, would be take yourself some alcohol and clean off the flux. And then you can get any, it'll help to cool everything off too, which is nice. It'll help to cool everything off as well. Alright, I think we're out of memory. Thanks for watching. We'll come back and do some bench testing.